Okay, so we've got 4 standard formulae that you've learned, and we're going to use the 4 standard formulae to prove a whole new formula, which is shown here. So we're going to start with the left-hand side, which is this, 2r minus 1 all squared. And the first step is to pull that apart. So we're going to multiply out the brackets, and get 4r squared minus 4r plus 1. And if you've written it like this, then you've gone wrong. You absolutely have to have brackets around it, otherwise it's completely wrong. Continuing to pull it apart, we have 4 times sigma r squared minus 4 sigma r plus sigma 1, and obviously the limits are the same, r equals 1 to n in every case. And that's the end of the first part. We've pulled apart our original expression into its constituent parts, and we now use the formulae that we've learned. The standard formulae, so sigma r squared is 1/6 n plus 1 to n plus 1. Sigma r is a half n plus 1. And sigma 1 is just n. So we've used the formulae there. Just going to simplify that because 4 times a 6 is 2/3. And 4 times half is 2. So that's the end of the second stage, substituting in from the standard formulae that you've learned. The third stage is the hardest one. We're going to we're going to pull out any common factor plus fractions. Fractions have to come outside the bracket. And to do that, we've got to look at what the common denominator is. In this case, it's 3. So I'm just going to write one more line to make it easier. I'm going to put everything over 3. The first term is already over 3. This one, instead of writing 2, I'm writing 6 over 3. And the last term, I'm going to write 3 over 3. That may look a bit silly, but it's going to make the third stage easier, because here we go. We're going to pull out 1/3, because that's common to all of them. We're going to pull out n, because that's common to all of them. And now a big bracket. The first term, all that's left is 2 times n plus 1 times 2n plus 1. The second term, we get minus 6 n plus 1, because we've already pulled out the 1/3 n. And the third term, we just got 3. So we should just check that by multiplying out. And the fourth stage is just to tidy up. Everything that's in the big brackets just needs tidying up. So I'm going to multiply out the brackets and then refactorize it. It'll take a few steps here. So first of all, multiply out these two brackets. We can get 2n squared plus 3n plus 1 minus 6 times n plus 1 plus 3. And so we get 4n squared plus 6n plus 2 minus 6n minus 6. Make sure that's a minus 6, not plus 6, plus 3. And then collect together like terms. You know what we're doing here. We're just going to make this into a nice quadratic. Plus 6n and minus 6n goes. Nice quadratic, and then we'll see whether that factorizes. So 4n squared minus 1. And we look at that and go, does that factorize 4n squared minus 1? Yes, it does. We recognize the difference of two squares. It's going to be 2n minus 1 times 2n plus 1. And that is the right-hand side. That's what we had to prove. So we finished. There were 4 stages to that, so just to remind you, the first step was pull it apart, and don't forget to use brackets. The second step is to use the 4 standard formulae, the ones that you learned. The third step is to take out fractions and common factors. In this case, we were taking out the fraction, which is 1/3, and the common factor, there was only one, which is n. Fraction, common factors, and then step number 4, tidy up. That's the method we use.